please.
Awesome, awesome. So, hi everyone, welcome and thanks for joining us today. So, as you all know, OLake runs technical sessions around Apache Iceberg, and we also run events as well, covering real world implementations, architectural patterns, and what's emerging in environments as well. So, if you're new here, I'll just take one bit to introduce OLake as well. So, what we do OLake is an open source data replication engine that syncs data from databases and Kafka into Apache Iceberg, supporting both full CDC and full load as well for continuous updates. And by the benchmarks, we deliver 5 to 500x faster sync and up to like we take 90% lower cost as well. So this is just one bit that I wanted to introduce ourselves. And here we have Andrew. So he is joined us today to walk through how Apache Iceberg becomes a substrate for AI agents, moving beyond storage into governed context layers for autonomous reasoning. He's the head of developer relations at Fivetran. And Andrew, please take the floor to introduce yourself and cover the agenda as well. Thank you so much.
Thank you. Thank you for having me. So, right now, Iceberg is growing in popularity, and as is AI and agents. And these two concepts don't necessarily have to intersect, but I'm seeing it more and more in the field how Iceberg is really enabling AI at lots of different levels. And so today we'll go through and just look at like what is the history of data systems? How did we get where we are? And why would Iceberg play a role in AI, specifically agentic AI? And I'll do a quick demo of a hybrid agent running on Iceberg. So this will be, happy to have an interactive session. Keep it loose. I'll share my screen here and we can get going. So share. I'll just share my full screen. That's fine.
Andrew, I'm just leaving the stage, but I'm right here. If you face any sort of issues, I'm right here.
Perfect. You know me well then, because I'm full of issues. So I'm sure we'll have some.
Okay, great.
Awesome. Well, thank you so much. So as was mentioned, I'm head of developer relations at Fivetran. Before that, I had a real job. I was head of data at a lot of different places. I built AI machine learning systems at a lot of different places, vice president of AI machine learning at JP Morgan, led analytics at Arizona State University, a bunch of different things. I was part of the Tabico team, which created SQL Mesh and SQL Glot, which was acquired by Fivetran, and that's how I ended up here. On the side, I'm a graduate professor of data science at a bunch of different places. But most importantly, I just got my silver play button on YouTube. So now my wife has to introduce me as an influencer. So we'll see how long I stay married. But for now, my official title in my household is influencer. So a brief history of AI. And I do want to keep it brief because it's really like when Stephen Hawking released the book, like the brief history of time. That's kind of like the brief history of AI. And that's how I feel about it. But I want to do something a little different here so that we're not bored out of our minds, but it'll help explain how we ended up where we are. So I'm going to share this screen. So if we think about data systems and where we are, like a lot of times when I'm consulting with companies and we start talking about AI, we start talking models and this and that, and should we fine tune or should we do RAG and blah, 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 blah. But how did we actually get here? And that actually has a lot to do with what your strategy should be going forward and explains the role that Iceberg has in these AI data systems. So if you think back to like the 1950s with AI, not AI, so data systems, and it's like, well, what did they look like? Well, they were really siloed. They were just there. They're hard-coded. They're big physical systems, and their only purpose is to support applications. That's really it. They're transactional databases, very difficult to work with. SQL doesn't exist. That's what we're dealing with. And the data didn't really talk to each other. So we had really isolated instances of data powering these different applications. Super transactional. We're just writing, really. We're not reading. We're not doing any of that stuff. So that really continues for quite a while. In the 1970s, we start getting relational databases, late 60s, early 70s. We get that paper from E.F. Codd where he's like, hey, what if these tables inside our databases could talk to each other? And we like had these things called primary keys, where before they were just really siloed, they didn't talk to each other. So we start getting relational data modeling inside these still isolated systems that are still just talking to apps. So we start getting more interconnectivity inside these systems, but not system to system. And we're still really just doing um, writing, and we're really just powering these apps. And it's really hard to get the data. Like these schemas are hard coded. If you want to change something, it's a nightmare. It takes a lot of expertise. And this is the state. But we made a lot of progress, and you see a lot of AI start progressing at this time as well. So neural networks really go back to the 1950s. We start seeing a little bit of improvement in the 70s, but in the 1980s, there's a big resurgence in both neural networks, but we see a lot of data systems start evolving as well. Because in the 80s, we see Bill Inman start talking about this data warehouse concept. So his thought is, hey, we've got these disparate systems that are supporting these applications, but we really can't get a single source of truth. And what if we were able to, one, get a single source of truth, but what if we were able, once we have this single source of truth, read some of that data and do this new thing called analytics? So that's the thought behind the data warehouse, where now it's like, oh, let's take this data, and this data, we've got this new concept called ETL, extract, transfer, load. We're going to put it into this single source of truth. At least that was the idea, right? And then we can do analytics. That's analytics. So that's the concept. And to make it even easier, in like 1986, now we get ANSI SQL. So that really helps power the analytics, because instead of having to be a hardcore computer engineer in order to access any of this data, we can use SQL in order to do reading. So this is a big deal, because before we couldn't really do reading because we didn't want to blow up the applications. The whole purpose of these transactional databases is to support the applications. So when Bill Inman comes in the 80s and is like, hey, let's ETL some of this data like overnight, so we're not messing with the applications, the transactional data. Let's get a single source of truth, and now we can do this thing called analytics. Awesome. Big boom. We start seeing, business analytics start blowing up in the 80s. Really great. And this is all just structured data, right? This is all rows and columns, which is great. Works super great for SQL, works really good for the data warehouse. But in the 2000s, we start seeing this new kind of data. So we've got the .com boom, and now all of a sudden we've got all this unstructured data. Now there's a lot of things that don't necessarily fit in rows and columns. And so what happens is now we start getting this concept of data lake. So we get Hadoop, which is really the first data lake. We start getting S3 rolls out with Amazon. So now in this data lake, we can start having unstructured data with, object storage, pictures, music, and, we could have rows and columns in there too. We start dumping all this data into the data lake because quote unquote storage is cheap, especially with cloud rolling out, right? I think in 2007, S3 rolls out on the cloud. So now we're just dumping all this extra data that we're pulling from the web into the data lake because quote unquote storage is cheap and it's valuable, we think. But What's actually happening is that our systems really still look like the 80s. We're just storing a bunch of stuff in the data lake, but we're not actually using it. So now we've got these disparate systems powering these applications, and we're trying to set up these data warehouses. But now what happened was sales wants a data warehouse, and HR wants a data warehouse, and marketing wants a data warehouse. And so now we've just got all these data warehouses and we don't have a single source of truth. And so Ralph Kimball's like, okay, well, if that's going to be the case anyway, why don't we do, data marts where we're just giving up the single source of truth, and it's marketing has their marketing data mart, and that's their source of truth, which it doesn't matter if that really aligns with the sales data mart because that's their source of truth. And so we start seeing these systems start just really diffusing across the landscape. And a lot of companies are still there where they just have tons of different storage systems all over the place. There is no single source of truth. Like, that's a joke um, in their minds. And that's where we're at when in 2016, 2017, Delta Lake rolls out, Apache Iceberg rolls out, and Apache Hootie rolls out all around the same time. Delta Lake rolls out a little bit earlier in 2016, and then Iceberg and Hootie in 2017. So, and this is what they're trying to deal with is, hey, we've got all this awesome data in the data lake and we're trying to use it, but I delete a column and it doesn't stay deleted, and there is no single source of truth, and I've got this huge diffusion of technology and data storage everywhere. Like, this is kind of a nightmare. And with Netflix creating Apache Iceberg, this is what they're trying to deal with. They're like, hey, we've got all these files sitting in the data lake, but these JSON and Parquet files, they're really a table, but there's no way to say it's a table. And also, there's no way to really govern and control the the transactions inside the data lake, which is a problem, right, for reporting. In order for it to be a ACID compliant database, where we can trust it, it needs to be able to have some kind of mechanism where we can manage the metadata and say, yes, this column is deleted and it's deleted for everybody. Or if these transactions happen at the same time, there's some kind of way to say, oh, this transaction was accepted, this was deleted, or some process there. So that's where Iceberg and Delta and Hootie roll out. And so it's essentially taking these files in the data lake and saying, okay, you are a table, and we are going to govern the transactions on this table so that if a column changes or whatnot, it changes for everybody. And now we can suddenly trust the data in our data lakes. But this was kind of it was tough. So I've been talking about Iceberg for years now, and I remember begging people to come to Iceberg meetups, and it was really kind of a niche topic. But in the last couple of years, it's really exploded. I think the Databricks acquisition of Tabular was kind of everybody saying, oh, okay, it's kind of validation. It was really like when we were talking about Iceberg, lots of enterprises were like, well, we don't know if it's going to be Delta Lake or Iceberg. We don't want to invest a lot of time and energy into migrating to one storage format if it's not going to be around in 5 years. Iceberg's kind of one. Unless you need a transactional database where Hootie is really good, excuse me, alternative. But Iceberg's getting better, right? So Iceberg still isn't a streaming and transactional database. It's getting there. It's just not as good as like Hootie, which was invented by Uber, and that's the use case for it. So Iceberg rolls out 2016, 2017, and it's really grown in popularity. So now where we're at in 2025 is now we still have a lot of this legacy storage from the 80s, but we have hope that now our data lake can kind of be the center of our universe, because we can now turn our files into rows and columns and govern them in an ACID compliance way through Iceberg. So that's where we're at. And so now as we start growing these AI systems, it's really, well, is Iceberg going to actually support what I need for AI? And my thesis is yes. And here's why. So when we think about the data that we need, you really line it up with AI capabilities. So, and I'm writing a book for So feel free to, to have logical discussions with me and we can talk through it. And there's lots of different frameworks that you can use. But if you think through like this history that we just looked at, like what's happening. So we've got raw data happening in the data lake space. And what can we do on raw data sitting in our data lakes? Well, when I was leading some data science teams, we were the only ones in the data lake because we could do deep learning on top of raw data. And it was really just us. It was the machine learning engineers in the data lakes doing, raw data. That's deep learning because it's perception AI, right? It's figuring out, is this a cat? Is this a number? So the data lakes really, uh, for a while, only supported, in my opinion, perception AI, which is deep learning, part of deep learning, because generative AI, a lot of it is also, deep learning. But then on top of that, the next level up is where 99% of the work has happened since the 80s is we've got this structured data. And this is really the foundation for a lot of machine learning, like the more basic machine learning where it's regression based or tree based or it's clustering. And I call this analytical AI because that's also the same requirements for doing enterprise analytics. So it's cleaned, it's deduplicated, it's human readable. The column names make sense, and so this is where like 99% of the work has been happening is in this level, the structured. But suddenly we've got this new AI type called generative, and all of a sudden, this generative AI needs a different type of data, and so it's contextual data. And so it's really taking that structured data, but it's putting context around it. And there's a lot of ways you can do it. You can do it with vector embeddings. You can do it with semantic layers. So we need this additional layer on top of our structured data that's going to enable generative AI. And it's really whether you're training your own model, which is very rare these days, or if you're doing a RAG using a foundation model and supplementing it there. And in 2025, really, agents have become much more commonplace because their capabilities are growing. We saw them in 2024, 2025. Now, 2026, agents are really making a huge play. And so I call this action data, where now this is where MCPs come in. This is guardrails. This is managing memory storage within your agent for multi-turn or chain of thought. Now, and that really needs to pull from the contextual, the structured, the raw. Like you really can't do one without the other. So where I see enterprises struggling is they come in, they're like, we want to do agents, or we want to do generative AI, and they want to start with the action data or the contextual data, but they can't because they haven't really solved the raw or the structured data first. Because you have to understand where your raw is coming from. It needs to be cataloged. It needs to be structured in a way that makes sense and is compliant. And then based on that, then you can start getting into ontologies and context. And do we need vector embeddings? Do we not? And then you can put your guardrails and your API configs and all of these things into your agents because they all really kind of balance one another. So this is where we're at. So the question is, well, what about Iceberg? Like this is about Iceberg and you're talking about like MCP and whatnot. So here's my proposal to you. I know I have all these slides and whatnot, but slides are boring. So we can look at the slides. Studies have shown, lots of studies. Anthropic has a really good one. Rice University has a really good one, that the better quality data, even a small amount of data, can power a smaller model and have as good or better results than a larger model with more data. So how I think about that is like now models are kind of commodities. Like, oh, the new Gemini rolls out. Now we've got the new OpenAI model rolls out, and we're getting these small incremental gains, but it's like, okay, if you have a superior model, it might be 1.1 times as good as the other model. So your models have kind of become commodities. Where your real value is going to be is in your data. So if you have crappy data, let's say it's not good. Like you really don't have the context. It's like halfway to the point where it needs to be. Well, now that's going to be like your performance is going to be awful. Even though you have a superior model, your data is going to hold it down. Where if you have an average model, even a subpar model, but let's say you have an average model, but you have superior data, and I don't think it's that hard to get superior data because the data out there, and related to your competitors is so bad. You're going to outperform. And I think Iceberg is key to this because if you look at the 4 layers of data, Iceberg can really cover for sure these 3: the contextual, the structured, the raw, and it can interact a lot with the action data. The action data can a lot of times live within the agent config itself and doesn't necessarily need to live in a database. So how that can work with Iceberg is that now, because in your data lake, you can just make that your single source of truth because you can have your raw data if you need it. You can structure that, deduplicate it into high quality models. We can add our context on top of it, either through a couple different ways. One, right now, you can get it out to a vector DB, but while maintaining your uh, Iceberg as your single source of truth. Very cool things happening with LanceDB where where you're able to store both embeddings and the data inside the Lance multimodal data lake, and Iceberg is moving in that direction itself. So soon you'll be able to store the context and the content next to each other. For now, if you need to vectorize something, then it's just going to need to use Iceberg as the source of truth and then vectorize what you need. You can add your semantic layer on top of it using something like DBT. And then you can use your MCPs. So if we have our agent and we use something like LangGraph, which we can do a routing model on top of. Well, now when we have questions of, oh, what was last month's revenue? Well, that's a deterministic question. So we could really do a SQL query or a text to SQL query to grab that from our semantic layer, interacting with MCP, or using our agent routing model. If it's a probabilistic question where it needs to interact with text, the unstructured data, it can go in and read the embeddings and return that way as well. So really the agent is able to interact with either text to SQL through deterministic questions and probabilistic questions through vector embeddings. I can do lexical search and those type of things. But it keeps Iceberg as your source of truth. So that way you don't have the same problem that we encountered in the 80s, which is really impacting enterprises today, of all this huge technology sprawl where data's everywhere. Keep it in Iceberg, get all the way up through your contextual data. If you need to do embeddings outside, that's great. Choose which data you need to actually have embeddings on, which is unstructured data that you can do probabilistic searches on. But most of the use cases for agents out there that I'm seeing in the enterprise is really deterministic. It's really text to SQL because text to SQL has gotten really good. So that's what's out there. In fact, I know a large company right now that's doing this model where they have vector embeddings on some of their data. They have a really good semantic layer on top of Iceberg on the rest of their data, and they're running multiple millions of the text to SQL queries per day. It's now a core part of their function. Giant company. I don't think I can name them because it was told to me in confidence, but there's a use case out there coming soon. So what that can look like, and my main demo is on my Mac machine. And so last night I frantically was like, oh shoot, my Windows machine is my streaming computer. Let me try to rebuild this. But here's like a basic demo way of how you could do this. So here's the stack. It's going to be Parquet files just ingested, and you could use Fivetran, different things like that to do your ingesting. You could do a self-service ingesting, whatever. For here, I'm just making up data, but in production, right, you want to have something that's going to ingest. So I'm ingesting Parquet files into Iceberg. I'm storing it in S3 compliant min.io on my computer. I probably should fire up Docker while I'm talking to you. And then, sorry, I need to get Docker running here. If I could multitask, my life would be so much easier. So I'm going to use Spark to ingest the data. I'm going to use Trino to read it. I'm going to use DBT to create a semantic layer on top of it. And then I'm going to use open source Spice AI to do the vector embeddings and also do the text to SQL. So I'll just walk you through my code because I know we're kind of at time. So just showing, here's the basic Docker stack, and I can share a GitHub repo after. So min.io is the S3 storage. Spark's going to ingest it. Trino's going to read it. Nessie is going to be my Apache Iceberg REST catalog. You could use Polaris. You could use Lakekeeper. I like Nessie because it's super simple for a demo. And then Spice is going to be on top of that. So I'm going to ingest this. I'm going to make a ton of fake data, right? And drop it in min.io, turn it into an Iceberg table, and govern it with Nessie. I'm going to take my DBT, super simple. It's just a bunch of tickets, and I'm just going to make a DBT layer on top of that as my cleaned data. And then in Spice, I'm going to take two different models. So I'm going to do a local embedding model running on my computer from Hugging Face. And I'm going to do Llama 3. It's going to be a small Llama 3 model. So let me get that up and going. And so Spice is actually what is doing this at scale in that. Let me remember how to do this in Windows. Yeah, last night I was like, oh no, I'm not going to be streaming on my Mac, and my demo is on my Mac. So let's fire up Spice here. Make sure that everything is up and running. Let me make sure my Docker Compose is going. Okay, that looks good. So let's fire up the Spice runtime. And I like Spice because at the instance level, you are able to govern access and credentials and all of that. So you could spin up a different instance for different role-based access, which is really nice. Oh, I need to close this out. Hold, please. So let me, I think there's another Spice instance running. So let me kill Spice real quick. That should be fine. And it's going to load. Okay, good. So we can see 99 rows have loaded from my DBT model. My Llama 3 for inferencing is ready to go. Bam. So now I can interact with it. And again, this is all open source, the way I'm doing this. So let's get a new terminal. So there's a few different ways we can do it. So like Spice could just do straight up SQL for deterministic things if you wanted to just do SQL itself. So you can see it's running. It gives me my top 5 tickets, shows me all the columns, all that fun stuff. Great. So that's if I actually want to write SQL. It can also do text to SQL, and it can do vectors. So you saw in that Spice config that it on that same data, I'm going to run embeddings on top of it. So as part of me running that Spice runtime, I embedded my data and I can do deterministic searches. Now, again, this was, sorry, I'm trying to type and think at the same time. This is made up data. So a lot of the text that I put in there is nonsense, but let's get an idea of what this is going to do. So I'm going to look for the text, login authentication problems. And this is, there's better ways to do this, but we're doing a quick and dirty demo. So you can see just based on the same data from my DBT model stored in Iceberg, I'm reading my vector embeddings with my score, the similarity score, right? And then on that same data, I can do all of these same functions. So I can put in text to SQL and say, hey, show me the different levels of criticality. Bam. So it's using this llama model. And because I'm running all of this locally, I probably shouldn't have a secret in there. Well, that's good. Well, now I need to go delete that secret. That was dumb. And you don't even need a secret for that, which is the really dumb thing. So inside my config, so running this llama model, and this is a fairly small model. So it's honestly not even that good with tool usage, but I'm able to use the tools to run text to SQL. I can have it interact with MCPs all on top of my Iceberg data. So this is, and then if I wanted to make this demo more robust like it is on my Mac, now what I do is I create a router model using LangGraph, and I can put in just a plain text question of, hey, what's the different level, what's the count of the different critical levels of tickets? And it can determine based on that router model, do I need to do a text to SQL or do I need to do a vector search? And then it can do that running through Spice AI. It can do either one. And so that is where Iceberg is going, and it's really going to start powering agents. And I'm really excited about what LanceDB is doing because the Lance data format, because Lance is both an engine and a format and a lakehouse, it's kind of a big thing. But it's proposed that potentially Iceberg can start using other formats like Lance or Vortex in the future, which is really going to start powering and making these agents easier to use. Right now, we can do it through MCP and those type of things. But soon, I really believe that you'll be able to move your context closer to your content and store it all in the data lake using Iceberg. And so that really continues with that single source of truth. You're able to hit all 4 levels of the data and AI capability, from raw and perception to structured and analytical to contextual and generative to action and agent. So I know that was a speed run, and it's a little bit reductive because, again, it's a demo, but I am seeing these things at scale running at enterprises right now. And I think this trend's just going to continue, and it's just going to be more and more prolific. So if you can get good at Iceberg now, the better off you're going to be. So I know we threw through all this stuff. We just did it in real time with RAG versus vector RAG, blah, blah, blah. So happy to share things out afterwards. But yeah, you really want to control your ingest through things like Fivetran, get it into Iceberg, and then from Iceberg, really control the 4 levels of data so that you can have a strong enterprise agentic system. All right, that was a speed run. I'm done. Everybody can now, relax.
Okay, awesome. Thank you so much. I think like it was one of the most interactive sessions we have hosted. Um, but yes, we have a bunch of questions as well for you to answer. And what I'll do is I'll just read out the questions for you so you can answer them real time. Is that okay?
Yeah, please do.
Okay, awesome. So, first question is from Tushar, and he says, "What are your thoughts on supporting APIs from Iceberg Data Lake? This can technically remove the need of any relational DB in a system where DB is maintained just to support ad hoc API calls from the data. The same data is being sent to Data Lake."
Yeah, it depends because some databases are purpose built. So and a data lake can't do everything that every database can do. There's definitely transactions that a data lake isn't great for, but I believe it's good for most use cases. Uh, Apache Polaris and like the using the Iceberg catalog as the endpoint is now becoming more useful, and there's a lot of work being done there with improving the API endpoint on Apache Polaris so that it is going to be much more interactive and easily accessible for building applications on top of. I don't think it's there yet, but it's emerging, and I think that's going to be a trend, and I think it's going to be a requirement in order to be the core of this agentic system. So I think it's all emerging, but the more simplifying you can do, the better.
Great. I hope, Tushar, that answers your question. But if you do have any follow up, you can mention up here. So, okay, we will move to the next question. Okay, Vishnu has one question. It was while you were giving the demo. So he asks, what do you mean by action data for the agent, chart context or context history?
Yeah. So there's a lot of different ways to structure your agent, and there's a few things that it's really the configurations and parameters around your agent, around how are you managing memory of different sessions. Does it have state? Is it stateless? And these are all configs that you can do based on how you set up your agent. It's also the guardrails and the models and the tools it has access to. It's the MCPs it has access to. It's making sure that it has like the most recent API information. And so it's really the configuration around the agent, which typically isn't stored inside of a a typical data storage location. It's really more in the building and configuration of the agent itself, which is why I think Iceberg really is still the core of an agentic system, because a lot of the data that you're not storing in Iceberg, outside of vector data, but for agents specifically, is really in the like the YAML files or the configurations that you're setting up with for the agent, or determining, how much memory does the agent have based on your conversation, or based on the MCP. Like, are you going to overload it with MCP information or not? And what size model are you going to use? So that's all like action data.
He has kind of a follow up question to this, actually. Like he just mentions again, but if the agent is writing a SQL query, assuming that the agent has context to the schemas of the DB, how is it different from connecting agent with a MCP server to the Postgres or any other DB? What is the point of Iceberg in it?
Iceberg centralizes everything. So Iceberg has all of your data in one spot across all the levels. So you've got your raw data, your structured data, and your contextual data. So you can have your raw files, your Iceberg tables, your DBT semantic layer on top of that. You could even use the DBT MCP and have the MCP write the SQL. It doesn't really matter. Um, why I have the agent write the SQL sometimes, not always, it depends on your system, is that you can train the agent on your query engine, right? Like, not all query engines work the same. So Mother Duck, for instance, is talking about why their MCP is working so well, and it's because they trained the agent specifically on DuckDB and how that works. So the purpose of Iceberg is really just to centralize everything, have a single source of truth, and be able to support all of your AI needs outside of the vectors, which is coming soon. At least it's potentially on the roadmap. That way, you don't have this sprawl that we experienced in the 80s, where you've got your Postgres and your Redshift and 40 data warehouses. And how are you supposed to do enterprise AI when there is no single source of truth? Iceberg fixes that question. But again, there's always going to be needs for transactional databases and whatnot. So it's taking your use case and understanding where should the application live. And a lot of times, I believe it's going to live on top of Iceberg.
Yeah, sounds rational. Yeah, I think we're end of Vishnu's question. Let's move on to another question. Okay, Vishwanath here asks a very layman question. He wants to know about your machine configuration. So,
Yeah, this one, and again, I do this live demo using my MacBook, which is over there. But I was like, oh shoot, I'm streaming. I need to do this on my Windows. So my Windows machine has 32 gigabytes of RAM. The Docker, I assigned 15 gigabytes of RAM to it, but I don't think it was running that. I think it's running it right now. It's only running two.
yeah.
So not that powerful, but yeah, I'm running everything 100% locally is the problem. So like if you have an open AI key and you don't want to use just like a local model, it requires much less RAM. It's just I put the whole model on my computer, both models, the embedding and the Llama 3. So that's why it takes a little bit more space to run it completely locally.
Okay, got it. Yeah, okay. Okay, Vikneshwara asks if the current demo application is hosted on GitHub.
I can't. So this one's not because I just wrote this last night in a frantic, but I can put my main demo, which uses LangGraph um, as part of LangGraph working and orchestrating Spice across different MCPs and whatnot. So I can put it in GitHub and make that public. Uh, I just haven't made it public yet.
Awesome, yeah. Okay, okay, next question comes from Ajit. He asks, does any Iceberg query engine directly support vector search? If so, how performant are they? Asking since vector search data structures are memory heavy in PostgreSQL like DB.
Yeah, I don't know. I'm trying
Hmm.
to think. There are multi-purpose engines that also work with Iceberg.
Hmm.
Um, that's something I would need to look at right now because I do most of my vector searches through other tools like Spice, but I don't know right now. Yeah,
Okay.
I would imagine there is probably a multi-purpose tool that works on top of Iceberg and vector search. I just don't. One doesn't come to mind.
Okay. Okay. Uh, Ajit, we might come around to that question later on as well if we find the answer to it.
Sure. Yeah, feel free to message me on LinkedIn and follow up with any questions.
Okay. So we have a couple of questions left. This is from Kavi Shankar. He asks, how can we extend Iceberg for unstructured and queried real-time data use cases?
Yeah, so real time, there is a lot of work being done there. You see IBM just acquired Confluent, and Confluent is really big on the streaming into Iceberg. Like that was their big thing for the last year is, oh, now we can stream into Iceberg. Iceberg's not a transactional database though, so it doesn't handle it the best, but it is getting much better. 2 years ago, you really couldn't do much streaming in Iceberg. If you needed real-time data, you had to go to Hootie for at scale, Apache Hootie. Iceberg's getting better, but I believe my if you were a big enterprise coming to me and saying, "How do I stream an Iceberg?" I would say you need to buy a tool, something like Confluent, in order to have 99% uptime and those type of things. But the unstructured data, I mean, it's just in your data lake. But the benefit of Iceberg is that you're structuring the unstructured data, and it has new types like the variant data type. There's generic tables that you're able to do, and then you can use Spark, Cosmos, which is the data fusion with Spark to use some of those tables. So there's a lot of work being done on that right now. Um, but if you were going to do it at scale as like a giant enterprise, like if you were Pepsi coming to me and asking and say, okay, you probably need to just buy Confluent until some of the open source tools catch up.
Okay. Moving on to the next question by Shubham. He asks, in the demo, where is the vector data stored? In Iceberg tables, Parquet, or Lance-based customer support for Iceberg, not open sourced yet?
Yeah, no, in this demo, it's stored in Iceberg. Everything is stored in Iceberg. So I embedded it and I dropped it in Iceberg. But because it's so small, that's how I'm able to make it work. I wouldn't do this at scale because Iceberg's not really meant for that. Um, so if you were doing this like with an enterprise that I talked to that's doing this at scale, Um, they they have both Iceberg. The Iceberg's their central source of truth, and that's where like all their data goes is structured. That's where their governance lives. That's where their semantic layer lives. That's what they use to build their graphs and ontologies on top of. And then they took their unstructured data that they really needed, because this is for an enterprise solution. So they took their unstructured data, like their company knowledge, and they put it in a vector database. So at enterprise at scale right now for embeddings, you're going to put that in a vector database, and then your agent or your generative, whatever you're using, needs to be able to determine, is this a question that I need to go to the vector DB on, or should I do a deterministic, text to SQL, which is lower cost and easier. Like, you don't want to do a probabilistic search on like, what were my last 5 transactions in this database. That's not how that works. It's really like, hey, what's the laws, like what's the travel policy for our company? That's a good vector probabilistic search. So if you want it to have access to both, that's how you would do that. So I'm seeing more specialized agents now, where it's like, okay, this one is my text to SQL and this one is my vector agent. But more and more, as the content and the context come closer together, agents are starting to route between them and then synthesize the results. Yeah. So in short, in my demo, it is stored in Iceberg, but I wouldn't do that at scale. It's not scalable the way I do it. You would want a vector DB at this point if you're a large enterprise.
Okay. Okay. So Ajit asks a rather important question. This is one question that I have also seen popping up a lot of times. It's about real-time up-to-date data is really important for AI system, but it's very challenging to ingest real-time data into Iceberg tables due to small file problem or too many commits. How do we tackle this?
Yeah, I don't know if you need real time data. I'd push back on that. Um, I think micro batch is fine for 99% of use cases. Like what there's I think there's very few use cases where a 5-minute latency is not okay. So I've seen this scale, and I've seen very small files for ingest, just at a very high frequency, not be a bottleneck for Iceberg. I know we have the small file problem, and there's ways around it with partitioning and whatnot. Um, Again, you can use things like Confluent to do streaming into Iceberg, but I'd push back on it. Like, I can't think of very many use cases where a 5-minute delay isn't okay, and you can definitely micro batch at scale with Iceberg. Like, I'm talking very small files at scale that I've seen consistently run at very small time frames, batch into Iceberg, and not be a bottleneck for large companies, even though the small file problem for sure can be real. But I think there's just ways around it.
Okay, thank you for this. We have another question from Vishnu. He asks, how does the agent know if the data is stored in vector DB or Iceberg? Is the agent going to run both of them and then merge the responses into its context, or does the agent has a context or where to refer to?
Yep, it's that, and that's that action data where you're essentially providing the agent information. So when you configure your agent, you help it know like what are like it's going to be semantically aware of what data is where, and it can do that by doing a quick MCP call. There's lots of ways to structure it. So there are times, like in my other demo on my Mac, where it doing the router, it can do both. It'll do the text to SQL and do the vector query, and then combine the results and return that one response as it does that iterative loop. Um, so it really just depends, and that's that action data of how do you want to structure your agent, and that's what you'll be thinking through is, do you want it to call an MC, like, do you want it for managing memory? Do you want it to store schemas all the time, or do you want it to take its best guess as to where it is and pull the metadata, small metadata, and see, is that where it is? Or do you want it to do both? Do you want it to go vector first? It just depends on how you want to route the query, and it's understanding your enterprise data what the use case is, and then the smart ways to manage memory. So unfortunately, there's not one easy way around it. It's really use case by use case, how you want to build that agent. And Harsha, you're on mute right now.
I am so sorry. I am so sorry. But I think that was last of the questions that people had to ask. But folks, if you do have any questions, feel free to ping Andrew on LinkedIn, and he would answer your question, right?
Depends. If it's too hard, then I'll ask Harsha the question. Just- yeah. I'm happy to talk to anybody, and please send me any follow-up questions.
Okay, so I do have a conclusory question for you, and this is something that I plus some folks in the community would really like you to answer this. Basically, what's that one missing piece in the open Lakehouse stack that would unlock the next wave of AI adoption?
Yeah, I think it's really the way that Lance is going with having multimodal lake houses at scale. And there's lots of people in Iceberg. In fact, people on the Iceberg PMC who are working super close with Lance. So I think that some of those concepts are going to converge. But I think once Iceberg can kind of catch up to the awesome things that Lance is doing, um, I think that's really going to unlock it, because Lance is so small, right? Like, it's going to be great, but how many companies are really adopting Lance? It's like another tool, even though it's superior in some ways. A lot of companies have already adopted Iceberg, like giant companies. So if we can just get those capabilities into Iceberg, then I think we'll see that really explode.
Okay, thank you. I think this ends the Q&A for us. Andrew, like before ending the webinar, do you have any questions for us, or do you want to say something conclusory here?
No, thank you so much for having me. Feel free to ping me on LinkedIn, see what I'm doing at Fivetran. We're all in on Iceberg and data lake houses. I'm constantly traveling all over the world at Iceberg things. So please come up and let's talk. And I'd love to learn more about what everybody out there is working on.
We are looking forward to hosting you in India.
I can't
For
wait.
sure. For sure. Let's do something this year itself.
Let's do it.
Okay, awesome, awesome. So actually, one thing, Manjusha here asks, where can we find the link to the demo?
Yeah, I need to open up my GitHub, and then
Yeah,
I will make that public. So I'll put it on LinkedIn after
yeah.
I fix my demo in GitHub. Maybe remove some secrets before I make it public. Oh
Absolutely.
man.
We will keep you updated, Manjusha. So yes, before ending this webinar, I'll just like take 1 minute of yours and share the links of the community links that we have, where we host webinars, conduct events, and keep you all updated about what's happening in the Iceberg community. So just give me a second. I hope my screen is visible to you guys. If anyone can let me know. Andrew, is my screen visible?
Yep, I can see it.
Thank you so much. So basically, we have GitHub link over here where you can see and try out OLake, and we are 500 plus community members strong on Slack, where we have contributors and we keep you guys updated of the Iceberg releases, updates, and the events and sessions we host. OLake releases and product updates are also posted here real time, and of course, to stay updated with us, here's our LinkedIn account to follow us as well. I will give you all the recorded links and the PPT as well, whatever you require after the session on email. So stay tuned for that. And thank you so, so, so much, Andrew. I really can't wait to host you to India next. And let's do more events like this. Thank you so much for saying yes to our outreach.
My pleasure. Thanks, everyone.
Thank you so much. Bye bye.
Bye.
Have a great day ahead.